I've heard some physicists say that the entire universe could be a single wave function in mathematical space.
It's quite possible, yes. The universe doesn't leak energy, presumably. It should be a conservative system, so we imagine that it hasn't decohered. It hasn't lost quantum coherence. Coherence is basically what keeps a quantum state quantum, which means that it can be on or off or on and off at the same time. It can have a property, or it can have another property, or it can have a certain trans-beingness of those two states that we don't know how to understand. Like, it can be a particle and a wave at the same time somehow. It can be up and down at the same time. We don't really know how to.
So what exactly is a wave function representing?
Oh, it's representing a set of possibilities that can manifest when you take a measurement. When you measure the system, it will take on a property from the wave function.
Where do these possibilities exist?
We don't know where they exist before we look. We know that we see evidence that the different possibilities somehow interfere with one another. And so, like when you see the double slit experiment, if you don't have a detector on one of the holes, you're firing an electron gun at a set of holes, you'll see that as you fire one electron and singly, or even a group of electrons, what you'll see is an interference pattern manifests on a detector screen at the end.
So what is it about a measurement that converts the possibility into an actuality?
The truth is that's an unsolved question. We don't know. So the thing about the measurement is that maybe perhaps somehow it's interacted with the classical universe in such a way that it brings it into this measurement outcome obvious way of being, and we don't know really what causes that. There are models of decoherence. There are the many worlds interpretation. I tend to be a fan of the Copenhagen interpretation, which is basically like we don't know what it's doing until we see it, and we don't know what it is about looking at it that makes it take on these properties.
So who is the we that's looking and measuring?
That's also a good question. Well, basically, everything in classical reality is made up of quantum reality at some level, but basically this thing called decoherence means that as the wave functions interact, certain aspects of the wave functions cancel, or they interact destructively, basically, so that some of the quantum features go away and we become solid, or the illusion of solid, or however you want to discuss it. It's an intersection of very abstract mathematical ideas with very concrete physical ideas, so it's hard to even think about and to find the right words sometimes to bring it down.
When I ask people where do these possibilities exist, where is the wave function, so a lot of them will say it's in Hilbert space. And then they say, what is Hilbert space? And they'll say it's a multi-dimensional, infinite mathematical space.
It's a model.
But where is it? Is it real?
Well, at a certain level,
or is it an idea?
It's an idea. It's a model. It's in our heads at some level. But I like to think that there has to be some place that these things are hanging out when we're not looking at them. I like to think about, like, if I was small enough, I mean, this is ridiculous, to fit on an electron and ride it around, what would I be seeing? I'd be seeing, like, here, there, everywhere, all at once. That's kind of what I imagine.
Available on CuriosityStream. Watch premium factual shows at curiositystream.com.